To ground a 12-inch water pipe, firstly, gather your materials. You will need a 12-inch water pipe, grounding clamps. You will need 2 of them, copper ground wire, a minimum of number 6 American wire gauge, a grounding rod, and conduit or electrical tape, which is optional. Secondly, dig a trench around the water pipe parallel to it and at least 6 feet away. The trench should be deep enough to accommodate the grounding rod and wire. Thirdly, install the grounding rod. Drive a grounding rod into the ground at the end of the trench, ensuring it extends at least 6 feet into the soil. Connect the grounding wire to the grounding rod using a grounding clamp. Fourthly, attach grounding clamps to the water pipe. Place grounding clamps around the water pipe at 2 different locations, approximately 10 feet apart. Make sure the clamps are in good contact with the pipe. Fifthly, connect the grounding wire to the clamps. Run the grounding wire from the grounding rod to the first grounding clamp. Connect the wire to the clamp using another grounding clamp. Continue the wire to the second grounding clamp and connect it in the same manner. Sixthly, insulate and secure the wire. This step is optional. If desired, you can cover the grounding wire with conduit or electrical tape to protect it from damage. Secure the wire to the water pipe using wire ties or other fasteners. Seventhly, backfill the trench. Once the grounding system is installed, backfill the trench with soil and tamp it down firmly. Eighthly, verify the grounding. Use a multimeter to measure the resistance between the grounding rod and the water pipe. The resistance should be less than 25 ohms for a proper ground. Note that if the water pipe is coated, you may need to use a special abrading tool to remove the coating before attaching the clamps. When working with electrical systems, it is important to follow all applicable safety precautions and local codes. Grounding is an essential safety measure in electrical systems, designed to provide a low resistance path for fault currents to return to the source, thereby tripping a circuit breaker or fuse and preventing electrical shock hazards. In the context of a water pipe, grounding serves to ensure that the pipe does not become energized due to a fault in the electrical system or from static electricity buildup. Water pipes, especially those made of metal, can conduct electricity, and if they are not properly grounded, they can pose a significant electrical hazard. The materials required for grounding a 12-inch water pipe are specifically chosen to ensure reliable and safe connection to the earth. The 12-inch water pipe itself is the object being grounded, and its size is relevant because it dictates the size and type of grounding clamps needed to achieve a secure connection. Grounding clamps are specialized connectors designed to bond the grounding wire to the water pipe. It is crucial to use clamps that are specifically rated for grounding purposes and are compatible with the pipe material to ensure a low resistance connection. 2 grounding clamps are recommended to provide redundancy and to ensure that the grounding connection remains effective even if one clamp becomes corroded or damaged. The copper ground wire serves as the primary conductor that carries fault currents from the water pipe to the grounding rod. A minimum of number 6 American wire gauge copper wire is specified to ensure that it has sufficient current carrying capacity to handle potential fault currents. Copper is an excellent conductor of electricity and is also resistant to corrosion, making it a suitable material for grounding application. The grounding rod is a metal rod, typically made of copper or copper-clad steel, that is driven into the earth to provide a direct connection to ground. The grounding rod should be long enough to penetrate the soil and reach a depth where the soil is consistently moist, as this helps to ensure a low resistance connection to ground. Conduit or electrical tape is optional but recommended to protect the grounding wire from physical damage and corrosion. Conduit provides a rigid protective barrier, while electrical tape can be used to insulate connections and prevent moisture from entering the wire. The first step in the grounding process is to dig a trench around the water pipe. The trench should be parallel to the pipe and at least 6 feet away to provide sufficient space for installing the grounding rod and running the grounding wire. The trench should be deep enough to accommodate the grounding rod and wire, typically around 12 to 18 inches deep. This depth ensures that the grounding wire is protected from surface damage and that the grounding rod is properly buried. The second step is to install the grounding rod. The grounding rod should be driven into the ground at the end of the trench, ensuring that it extends at least 6 feet into the soil. This step is necessary to ensure that the grounding rod makes good contact with the earth and provides a low resistance path for fault currents. A grounding clamp is then used to connect the grounding wire to the grounding rod. The clamp should be securely tightened to ensure a good electrical connection. The third step is to attach grounding clamps to the water pipe. The grounding clamp should be placed around the water pipe at two different locations, approximately 10 feet apart. This spacing helps to ensure that the grounding connection is effective and that the pipe is properly grounded. It is important to make sure that the clamps are in good contact with the pipe. This may require cleaning the pipe surface to remove any dirt, rust, or corrosion. The fourth step is to connect the grounding wire to the clamps. The grounding wire should be run from the grounding rod to the first grounding clamp and connected using another grounding clamp. The wire should then be continued to the second grounding clamp and connected in the same manner. This creates a continuous grounding path from the grounding rod to the water pipe. The fifth step is to insulate and secure the wire. This step is optional but recommended to protect the grounding wire from damage. The grounding wire can be covered with conduit or electrical tape to protect it from physical damage and corrosion. The wire can also be secured to the water pipe using wire ties or other fasteners to prevent it from moving or becoming disconnected. The sixth step is to backfill the trench. Once the grounding system is installed, the trench should be backfilled with soil and tamped down firmly. This helps to protect the grounding wire and grounding rod from damage and ensures that the grounding system remains in place. The seventh step is to verify the grounding. A multimeter should be used to measure the resistance between the grounding rod and the water pipe. The resistance should be less than 25 ohms for a proper ground. If the resistance is higher than 25 ohms, it indicates that the grounding connection is not effective and that further action is needed to improve the grounding system. This may involve driving the grounding rod deeper into the ground, adding additional grounding rods, or improving the connections between the grounding wire and the clamps. It is important to note that if the water pipe is coated, it may be necessary to use a special braiding tool to remove the coating before attaching the clamps. This ensures that the clamps make good contact with the metal of the pipe and that the grounding connection is effective. When working with electrical systems, it is important to follow all applicable safety precautions and local codes. Electrical work can be dangerous, and it is important to take steps to protect yourself from electrical shock hazards. This includes wearing appropriate safety gear, such as gloves and eye protection, and turning off the power to the circuit before working on it. It is also important to consult with a qualified electrician if you are not comfortable performing the work yourself. Grounding systems play a vital role in ensuring the safety and reliability of electrical systems. By providing a lower resistance path for fault currents, grounding systems help to prevent electrical shock hazards and protect electrical equipment from damage. Proper grounding is essential for all electrical systems, and it is important to ensure that grounding systems are properly installed and maintained. Water pipes are often used as a grounding electrode because they provide a convenient and readily available connection to the earth. However, it is important to ensure that the water pipe is properly grounded and that the grounding connection is effective. This involves following the steps outlined above and verifying the grounding connection with a multimeter. In addition to grounding water pipes, it is also important to ground other metal objects that could become energized, such as metal enclosures, equipment frames, and structural steel. This helps to create a comprehensive grounding system that protects people and equipment from electrical hazards. Grounding systems should be inspected regularly to ensure that they are in good condition and that the grounding connections are secure. Any damaged or corroded components should be replaced immediately. It is also important to test the grounding system periodically to ensure that it is still effective. This can be done with a multimeter or a ground resistance tester. If the grounding system is not effective, it should be repaired or upgraded to ensure that it meets the requirements of the electrical code. Proper grounding is an essential part of electrical safety, and it is important to take steps to ensure that electrical systems are properly grounded. By following the steps outlined above and consulting with a qualified electrician, you can help to protect yourself and others from electrical hazards. Grounding is also crucial for electronic equipment because it shunts away excess noise and electromagnetic interference, leading to better performance and longer lifespan. Proper grounding not only ensures safety, but also the reliable functioning of sensitive electronic devices. It's also good to understand the difference between grounding and bonding. Grounding connects electrical systems and equipment to the earth, providing a path for fault current. Bonding, on the other hand, connects non-current carrying metal parts together to create a low impedance path for fault currents, ensuring all bonded parts are at the same electrical potential. Both grounding and bonding work together to enhance electrical safety.